In my previous video about the quadrotor, I confirmed that the quadrotor can lift off from the surface, which means that the motors, propellers and the mass of the quadrotor are well balanced. I immediately started writing the controller code. I implemented the calculation of the quadrotor's orientation angles based on the accelerometer readings and PID controllers. However, for effective debugging, it was necessary to understand what was happening inside the controller. The right approach to make progress on this task is to display and analyze raw data. I can output it via UART, however, this is quite inconvenient. The heart of my quadrotor is an ESP32 MCU which supports Wi-Fi. I set up a TCP server on it and decided to create a visualization using JavaScript on an external PC. Here is what I achieved. The first graph shows the data from the remote control. We are interested in 4 channels. Now my assistant will move the joysticks and we will see the real-time response on the graph. The second graph displays the data from the IMU with 6 parameters in total, 3 from the accelerometer and 3 from the gyroscope. The third graph shows the angles calculated by the controller. The controller estimates 2 angles, roll represented in red and pitch represented in yellow. The angle values are displayed in degrees. In addition to the angles, I created a simple quadrotor model using the same JavaScript. It visually shows how the controller perceives its orientation in space. Additionally, the spheres representing the motors are color-coded based on the power the controller applies to them. The last graph shows the operating frequency of my MCU. I haven't optimized it yet, this is just the first iteration. But even now I see a frequency of 10-15 Hz, which is decent considering I am writing to both the UART and the TCP server. Hopefully all these graphs will help me debug the controller and start flying soon.